10.2, hypothesis test for a population proportion. So we're going to specifically look at proportion here with our hypothesis testing. All right. So let's suppose here that we have a politician they have this firm, and they sample 1,000 voters and finds that 534 are in favor of a policy. So we get a proportion there of 0.534. Do these results suggest that among all voters, more than 50% favor the policy? Or is it possible that the true proportion is 50% and we just happen to survey a group that was in majority? All right, so that's what we want to look at. Is it statistically significant? I'm going to struggle with that words quite a bit here, so bear with me on those to conclude otherwise. All right. All right, so when observed results are unlikely under the assumption that the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis. All right, so first we need to build a probability model here. Now we base all of this off of is it normal or not? So first we need to see if we have our size. So we look at our n times p times 1 minus p. And is that greater than or equal to 10? In which case we see here that it is. Okay, and so we're talking about our overall population, so we know that we fit within that. Okay, so our mu here of p hat is 0.5, and then our standard deviation is 0.016. Okay. All right, and so we want to look there at that, so we can see here this is what one standard deviation would look like for those pieces. All right, now for a classical approach, we can consider that anything that is sufficient is too many standard deviations is going to be 2. So anything greater than 2 standard deviations away from the mean, we're going to say is statistically significant. All right. Okay, and so when we put that in here, we would see that we do get that our z-value is 2.15. So therefore, because that's greater than 2, we would reject the null hypothesis. Okay? All right, and so we would see there that that is such a small percentage is why we do that for those. So the area to the right of z equals 2 is that little bit. Okay? All right. Now, we call that the classical approach, with that being too many standard deviations away from that, okay? All right, now there's also another one that's called the p-value approach, okay? And so that's finding some probability with this, all right? So we want to look at the probability that p hat is greater than 0.534, okay? So here is that equation for that. Now, both of these equations can be found done in the calculator instead of by hand. So let's go back to the very beginning of this problem so that we can get the information that we're going to need for this, okay? And then we'll scoot back through these here and make sure, okay? All right, so here we are. Again, we have all these pieces. So let's turn our calculator on. So we need to go to different places here. We need to go to stats, and then over to tests. Okay, so we're going to do stat, over to tests, and then we're going to go down to one prop z test. Okay, one prop z test here. So number 5 on my calculator. Okay, and so then we're going to select what we need for these. Okay, all right. So we know that our p hat, or p sub 0, initial one, is 0.5. That's what our null is. We're suggesting that we're at 50%, so 0.5 there for those. Okay, now we know that our x value, that's how many were in favor here, was 534 out of 1,000. Okay? Now we want to know, is it actually greater than this, right? Because we came up with it being greater than. Is it actually greater all the time or not? Okay, so we're going to go over and make sure that the greater than is selected for those. Now we're not going to care about the drawing or the color. We're just going to go down to calculate and it's going to spit out our answers. Okay, so now we go back through our pieces here. We can see, all right, so here we see that Z is 2.15, just as was calculated by hand. All right, so we were able to find that right there. Now, if we were to go on to our p-value here, well, they got 0.0158. Well, so did we. We round that 7 up to an 8 because of the 6, and we get 0.0158, just like they did there. So our calculator, through this one prop z test, will calculate both the z-score and the p-value for us, okay, for those pieces. Now, that p-value is the probability, so that is about 2%. So that means 2 out of 100 would likely give us the probability is really 0.05, okay? Which is very unusual. It's less than 5% is usually what we talk about there. So anything less than 0.05 we would consider being unlikely or unusual, and so therefore we would reject the null hypothesis. Okay? And so again, the p-value is the probability of observing a sample statistic as extreme or more extreme than one observed under the assumption. Okay? All right, and so the lower the p-value, the stronger the evidence against, the more likely we're going to reject the null hypothesis, okay, for those. And so here we kind of go through those same things, but again, we're going to be looking at 5.05. If it's less than 0.05, we're going to reject those, okay? And so that's what we assume here for them. All right. All right, so let's look at some others here. Now, again, we need to remember what we talked about in 10.1, the difference between two-tailed, left-tailed, and right-tailed. So we need to be able to set those things up based on what the information is given for us. Okay? And so we want to also look at our level of significance, alpha, and that's also going to play a role in our pieces. Okay? All right. And some other things pop up there, but they're okay. We know that they're going to be just fine. All right. So they'll be looking at the tables and all of those pieces. So let's get on through all of that for them. So it goes through all of these. So let's just get to our example. So we're going to kind of click through. There we go. All right. So Humira, they're doing this trial. They have 705 subjects. Of those subjects, 66 reported nausea as a side effect. It is known that the placebo who report nausea is a side effect of 0.08. Does this sample suggest that there's actually a higher proportion? Okay, when we use a level of significance of 0.05 for alpha. All right. Now, what we're going to do is we're just going to go ahead and do it both ways in the calculator here. So let's turn our calculator back on. We're going to go to Stats. We're going to move over to Tests and down to number 5. So we see that our p-value there is 0.08. Okay. There were 66 reported out of 705. And we want to believe in that a higher proportion. So higher means greater than, and we want to calculate. Okay, so we're seeing a z-score of 1.33 and a p-value of 0.09 for those pieces. Okay, so let's look at what they have here. So just what we talked about there, we picked the greater than just as they did. for those. Our level of significance is 0.05. Okay, we checked, it was normal. We did our normal pieces there. So the p-value is 0.094, which is, or the p-hat value, sorry, is that. We have that as over here as well, which is a good thing. Now the z-value, 1.37. The calculator does calculate a little bit differently because of rounding error on those, but we're within range of that, which is still less than 2, so we would not reject here. Okay. But it's also our significance. We also need to remember 0.05 level of significance is going to be 1.645. Remember that from the table. That's a 95% on those pieces. So you can also go back and look at those things. So that's something we need to remember there as well when we're looking at our level of significance for those. So we're comparing it to that z of 0.05 on those. So you can always find that. That's the 1.645 on those. Okay. So 1.33 or 1.37, both of those are less than 1.645. So we do not reject the null hypothesis. Okay. All right, now what about doing it by the p-value? The p-value, when we calculate that here, is going to be 0.085. We got 0.091 on those. So based on however you do those things, you're going to get those values. Okay, you can see here that when they put it in Minitab, they got what we got as well. So it's okay for those values. All right. All right, now 0.085 or 0.09 is both are greater than 0.05. And so in that case, we do not reject the null hypothesis. Okay. All right, now what about the other styles? Let's look at a two-tailed. All right, so here again, we have the survey happening. We have 24% of all Americans said raising a girl was easier. They had 1,500 adults, 408 felt it was easier to raise a girl. Does this result suggest differently? Okay, so we have stat here. We're going to move over to test, down to 5. Okay. All right, so we know here that our probability is 0.24. Okay, now if we go back here and look at our numbers, we saw there were 408, and then out of 1,500, and this time it's a does not equals. They just say differently with them. They say it's not a less than or greater than on those, and then we want to calculate. Okay. All right, so again here, we can look at those. So our level of significance is 0.05 with us. We do fall within normal pieces. So our z-value is 2.90. Okay. Now, we want to look at our values there. They're actually, because it's a two-tailed, we need to split apart our alphas. So instead of 0.05, we're going to look at 0.025. On those, which is a negative 1.96 and positive 1.96. Well, 2.9 is still bigger than that, and so we're going to reject the null hypothesis. Okay. Now for our p-value, we can see it there as well. It's 0.0038 or 37 in our case on the calculator. On those, and so when we look at those, they get the same things that we do as well. But we compare that to our 0.05. That is less than 0.05, so therefore we reject the null hypothesis. Okay. So there is enough evidence to reject. All right, So here, using confidence interval, 34% of teenagers text while driving. Then we had a survey. We found 353 out of 1,200 with this. So they suggest that the proportion of teens who text while driving has changed on those, using 95% confidence interval to answer the question. Okay? All right, so again, I would look at doing my stat. We'll go over to test, down to number 5 for those. Okay, so 0.34. What's it, 353 out of 1,200. Now again, this one should be does not equal. So they just say that it's changed. Okay. And so we would calculate there for those. So I give some really small numbers there. So we could say those numbers. But we could also just use find our confidence interval. We could find our lower bound and our upper bounds for those things and calculate it that way as well from those. So we could either find our lower bounds and find out that 0.34 is not within it, or we could look at our z-values or p-values there and be able to do those as well. Okay. All right, now sometimes things don't come out to be normal, and so we need to look at what's happening here. So for instance, in this problem, we see that we have 48.9 males consume daily requirement of calcium. And so here they went and did a survey, and out of 35, 21 consume the recommended daily allowance, all right, for those. But when we go and looking at those pieces, even though we think it's going to be different than that, we don't meet the requirements for normal because our n times p times 1 minus p is less than 10. Okay? But this is a yes or no. They either do or they don't. So that's a binomial piece. Okay? And so since it's a binomial, then we can do our binomial CDF that we looked at previously. Okay, so that's a reminder of putting that in the calculator that way. Now, because it was a greater than, binomial only does less than in the calculator, so we do 1 minus for those pieces. And then we could find that probability. Okay? And so the 0.12 is greater than 0.1, which was the significance level on those. And so we would conclude that it has increased in this case. All right. All right, so those are the things that you're going to be using here in 10.